We need to find the number of solutions here, but also the sum of the solutions. So essentially we are trying to solve this. A good approach is going to be to get a sketch down. That will definitely help us out when we're eliminating solutions and so on. Although you could in theory do this without, just by removing the modulus signs carefully and thinking about where causes positive and negative. But I think this is good to actually get a sketch down. So um, right, let's look at cos x between 0 and 180. So it just comes down and then looks like that, which means when I take the modulus, it's going to come down, but then just bounce back up. All right, so that's that graph sorted. Now, what is going to happen when we square? If I square, it's going to sort of, like, it's still going to hit the one. You're going to get a slightly different shape, but it is going to sort of look a little bit like that, I think. And then if I make it negative, then it's just going to be like that again, but below the axis. And if I double it, it's then gonna, yeah, it's gonna stretch. And if I add one, it's then just gonna be moved up. So it still is back there. So I think I can now roughly draw what this would look like. It's gonna hit -1, but then it's gonna hit 1 here, then come back down to -1 here. Something like that. In fact, in second year maths, you'll learn that cos 2a is identical to 2 cos squared a minus 1. So in fact, this 1 minus 2 cos squared x is precisely minus cos 2x. It's pretty neat. That's not something that you'd know potentially, like in this question. I got to say, I actually did use it to draw the sketch. But anyway, it's there for the future. Right, so what I actually immediately see is that there's two solutions. Okay, well that's already given me a 1 in 2 chance if I wanted to guess, but if I wasn't sure how to solve it. But arguably the sketches are harder than solving. As we can look at two situations then. So if x is between 0 and 90, the modulus is not doing anything. It's your normal positive cos, or non-negative at least. 0 less than or equal to x, less than or equal to 90. We will get 1 minus 2 cos squared x equals cos x. That means 2 cos squared x plus cos x minus 1 is equal to 0. Then I'll get a plus 1 here, minus 1 here. Cos x is equal to a half, or minus 1. Um, but we know in this region that cos x is never minus 1, so I would reject that one. Actually, remember, it's when it's 180 that it's minus 1. That's beyond our range. Cos x equals a half, however, does have a solution, and it's 60. That is that solution here. You can also see from the graph, yeah, that looks about right. And then what about 90 to 180? And now the modulus is kicking in, and I would get 1 minus 2 cos squared x equals, now because this thing inside here is negative, I then make it negative again to make it positive. So it's going to equal minus cos x. I'll get 2 cos squared x minus cos x minus 1 equals 0. Factorizes in a similar way. So I'm going to get a minus 1 here and a plus 1 here. So cos x equals 1. And we know we can reject that one again because we know actually cos x is going to be negative, or minus a half. And that ends up giving x equals 120 degrees. Okay, so you have to sort of know these values, but you can use the symmetry of the cos curve because it hits a half at 60, and then that is 30 away from 90. It makes sense because of the symmetry that it's then going to be 120 where it's minus a half. There we go. Those are our two solutions. And the sum is therefore going to be 180. So it's A. Well done.